In today's lesson, we're going to be studying scientific notation. Scientists and engineers often have to deal with numbers that are very large or very small. Okay, and by very small, I don't just mean the numbers like 1 or 0, all right, but I mean much, much smaller numbers, all right? So, for example, the distance from Earth to the Sun is about 93 million miles. That's a very large number, all right? Or the mass of a dust particle is about 0.0000000000753 kilograms. That is a very, very small number. Scientists have come up with a way to express these types of numbers without having to show all of the decimal places. This is known as scientific notation. Scientific notation depends a lot on integer powers of 10. And so in our first couple of examples, we're going to review our powers of 10. All right, so example number 1, evaluate each power of 10. 10 to the second power, or 10 squared. If we recall, that means to do 10 times 10, and that's just going to be 100. Letter B, 10 to the third power. Well, again, that's 10 times 10 times 10. 10 times 10 we said was 100. 100 times 10 is going to give us 1,000 when we do the multiplication. Okay, so hopefully based off of these two examples so far, you've noticed a little pattern. 10 to the second power is just 1 with 2 zeros after it. 10 to the third power is 1 with 3 zeros after it. So in the case when you're working with a positive power of 10, the exponent is going to tell you how many zeros are following the 1. So when I have 10 to the seventh power, all right, I'm going to write that as 1 with 7 zeros after it. 1, 2, 3, 4, 5, 6, 7. And now I'll put my commas in here so that I can see what my number is. And that's going to be the number 10 million. 10 to the 10th power is going to be the number 1 with 10 zeros after it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Put in our commas. And this time, notice that we get the number 10 billion. Okay, so if you're working with a power of 10 and your exponent is positive, the exponent simply tells you how many zeros follow the 1. In example 2, notice now that the exponents are going to be negative. They would like us to write each power of 10 as a fraction and then as a decimal. All right, so looking at example A, we have 10 to the negative first power. If we recall from our exponent properties, we can rewrite a negative exponent as a positive exponent by using the reciprocal. 10 to the negative first power is the same as 1 over 10 to the first power. And 10 to the first power, well, that's just 10. So that would be equal to 1/10. There's our fraction. And the fraction 1/10 is equal to the decimals 0 and 1/10. In example B, we have 10 to the negative second power. So again, I'll use the reciprocal to make my exponent positive. That's going to be 1 over 10 to the second power. And this time we're going to get 1 over 100. 10 squared is 100. And the fraction 1/100th is equal to the decimals 0 and 1/100th. Let us see 10 to the third power, negative third power. Use the reciprocal to make it positive, 1 over 10 to the third power, which when we evaluate 10 to the third, that's just going to be 1 with 3 zeros, or 1,000. So we get 1/1000th. And then the fraction 1/1000th is equal to the decimals 0 and 1,000th. All right, finally, with example letter D, 10 to the negative fourth power. Use the reciprocal, that's 1 over 10 to the fourth power. And then when we evaluate 10 to the fourth power, that's a 1 with 4 zeros, or 10,000. So 1/10,000th. And now when we write our decimal, that's going to equal 0 and 1/10,000. 10, 100,000, 10,000. That's what 1/1000th would look like. All right, so again, the exponent, when it's a positive number, that tells you how many zeros are going to be after the 1. Notice down here when the exponent is negative, that tells you how many zeros are going to be before the 1. 10 to the negative first power, 0 and 1/10. There's 1 0 ahead of that 1. 10 to the negative second, 1/100th. There's 2 zeros before that 1. All right, that pattern continues with the other negative exponents that we see. So now that we have a better understanding of powers of 10, let's see how they can help us with scientific notation. Scientific notation involves finding the product of a number and a power of 10. Let's investigate what happens when you multiply by a power of 10. In example 3, rewrite the power of 10 in standard form and then give the product. So with letter A, we have 6 times 10 to the second power. Well, 10 to the second power we know is 10 times 10 or 100. So this is really saying 6 times 100, which we all know will be 600. In letter B, we have 4 and 5 tenths times 10 to the third power. 4 and 5 tenths times 10 to the third is the same as 4 and 5 tenths times 10 to the third power, 10 times 10 times 10, which is 1,000. Okay, if we were to multiply 4 and 5 tenths by 1,000, we would end up with the number 4,500. And hopefully, based off of these two examples, you notice what is happening. Okay, for our first example, we took the number 6, which is the same as 6 and 0 tenths, and when we multiplied it by 100, we got the number 600. Remember that mathematically, when you multiply by 100, the decimal point ends up moving to the right once, twice, and that's how we ended up with 600. Here in letter B, when we multiplied by 1,000, we took that decimal on 4 and 5 tenths, and we moved it once, twice, 3 times until we ended up with 4,500. Okay, so by multiplying by 100, the decimal moves 2 times to the right. By multiplying by 1,000, the decimal moves 3 times to the right. Okay, so we can easily get these products when we do the multiplication by paying attention to the exponent of the power of 10. That exponent is going to tell us how many times we need to move the decimal point on our other number. So in letter C, when we see 1 and 5 hundredths times 10 to the fourth, I'm going to take 1 and 5 hundredths, and I'm going to move that decimal once, twice, 3 times, 4 times, and fill in with the zeros, which is going to give me the number 10,500. In letter D, we have 3 and 194 thousandths times 10 to the sixth power. So I'm going to take my number 3 and 194 thousandths, and I'm going to move that decimal point to the right 6 times. 1, 2, 3, 4, 5, 6. Fill in with the zeros, and we're going to get the number 3,194,000 as our product. So what do you notice about the product and the scientific notation? Okay, well, the exponent on the power of 10 tells us how many times to move the decimal point. All right, if we just pay attention to that exponent on the power of 10, all right, that says to move it twice to the right. We did to get 600. Move that 3 times to the right. We did that to get 4,500. Move it 4 times to the right. Move it 6 times to the right. The exponent on the power of 10 tells us how many times that we need to move the decimal point. So in example number 3, each of the exponents was a positive number, and that positive exponent told us how many times to move our decimal point to the right. Here in example number 4, notice that all of the exponents are negative. Rewrite each problem involving a division by a power of 10 and then give the quotient. So looking at letter A, we have 5 times 10 to the negative first. Well, that's the same as doing 5 times 1 over 10 to the first power, which is really the same as doing 5 times 1/10. Okay, and when I do 5 times 1/10, I end up by getting 5/10. And we're going to keep 5/10 as the fraction, but write it as a decimal, 0 and 5/10. Okay, so notice what really happened here. We took our number 5, which is the same as 5 and 0/10. And in order to get to 5/10, this number down here, we took this decimal and we simply moved it one time to the left. Okay, so 5 times 10 to the negative first, I moved that decimal point on 5 once to the left. All right, look at letter B. We have 4 and 5/10 times 10 to the negative second power. That's the same as 4 and 5/10 times 1 over 10 to the second power, which is the same as 4 and 5/10 times 1 over 100, which, if we think about it, is 4 and 5/10 over 100. Okay, so we're going to end up dividing 4 and 5/10 by 100. Well, if I had my calculator here, 4 and 5/10 divided by 100, notice I get the number 45 thousandths. Okay, 4 and 5/10 over 100 is equal to 45 thousandths. So again, notice what we did here. We took the decimal 4 and 5/10, and to turn it into 45 thousandths, I had to move the decimal back once, twice. Okay, so 4.5 times 10 to the negative second made me move the decimal point to the left 2 times. So now I hope that you're noticing that the exponent, the absolute value of that exponent, is telling us how many times that we need to move the decimal point, and the negative symbol is going to tell us to move it to the left. So exponent of -1, once to the left. Exponent of -2, twice to the left. 9 and 87 hundredths times 10 to the negative fourth power. That's 9 and 87 hundredths times 1 over 10 to the fourth power, which is 9 and 87 hundredths times 1 over 10,000. Okay, so this time we're going to take that decimal point and we're going to move it to the left 4 times. So 9 and 87 hundredths, move it once, twice, 3 times, 4 times, and fill in with those zeros. And we get 0 and 0.00987 tenths, hundredths, thousandths, 10,000, 100,000, millionths. This is 987 millionths when we write it as a decimal. Finally, we have 1 in 25 hundredths times 10 to the negative sixth power. That's 1 in 25 hundredths times 1 over 10 to the sixth. And 10 to the sixth is a million. So this is 1 in 25 hundredths times 1 millionth. So again, I'm going to take that decimal point on 1 and 25 hundredths. And this time I'm going to move it left 6 times. 1, 2, 3, 4, 5, 6. Fill in with all of those zeros. So we have 1, 2, 3, 4, 5 zeros, 0 and 1, 2, 3, 4, 5, and then 1, 2, 5. Tenths, hundred thousandths, 10,000, 100,000 millionth, 10 millionth, 100 millionth. This is 125 hundred millionths. What do you notice about the scientific notation and the answer? Negative exponents will tell us how many times to move the decimal point left. Okay, so again, the absolute value of the exponent will tell you how many times to move the decimal point. The direction is going to be to the left since the exponents are negative. So in our box, we have a nice little summary of what we've done so far. It should be clear that when you multiply a number by a power of 10, you either move the decimal point to the right or to the left. Multiplying by 10 to the nth power moves the decimal point n spaces to the right. Okay, when that exponent is positive, move the decimal point that many times to the right. Multiplying by 10 to the negative nth power moves the decimal point n spaces to the left. Okay, so if you just pay attention to the sign of the exponent, you will know right away if you're moving your decimal point to the right or to the left. Now that we have discovered how to multiply by powers of 10, we will learn how to write very large and very small numbers in scientific notation. We'll essentially reverse the process from example number 3 and example number 4. And you can actually write any number in scientific notation. Example number 5. Write each number as a product of a digit between 1 and 10 and a power of 10. Okay, so let's think about the number 50. All right, the number 50. How can I write that as a number between 1 and 10 multiplied by a power of 10? Well, 50, I know, is divisible by 10. And in fact, 50 is the same as doing 5 times 10. All right. So if I think about how I've got this written, here's my number between 1 and 10. That's the number 5. And I need a power of 10. 10 by itself is 10 to the first power. So 50 is the same as 5 times 10 to just the first power. 10 is the same as 10 to the first power. In letter B, we've got the number 300. Okay, write this as a product of a digit between 1 and 10 and a power of 10. All right, well, if I think about powers of 10 here, 10 can go into 330 times, but 30 is not a number that's between 1 and 10. So I'm going to use a different number. I'm going to use the number 3, and 3 times 100 is equal to 300. So there's my number between 1 and 10, and I've got to ask myself, how do you write 100 as a power of 10? Well, that's going to be the same as doing 3 times 10 raised to the second power. 100 is the same as 10 squared, so 300 is the same as 3 times 10 to the second power. Let's try a tougher one, a decimal this time. 4 tenths. 4 tenths. Well, again, I've got to figure out how I can write this as the product of a digit between 1 and 10 with a power of 10. All right, 4 tenths is the same as doing 4 times the decimal, or the fraction rather, 1 tenth. 4 times 1 tenth. All right, so 4 is my number that's between 1 and 10. And now for my power of 10, well, I'm going to have 4 times 1 tenth is the same as 10 to the negative first power. Okay, if we recall, 10 to the negative first is the same as 1 over 10 to the first, which is 1 tenth. So 4 tenths is the same as 4 times 10 to the negative first power. Finally, 7 thousandths. Well, again, I'm going to multiply it as a digit between 1 and 10 with a power of 10. My digit between 1 and 10 is going to be 7 times 1 thousandth this time. 7 thousandths is 7 times 1 thousandth, which is the same as 7 times 10 to what power? Well, 1 1,000th is the same as 10 to the negative third power. Remember, 1,000 is a 1 with 3 zeros after it. Since it's a fraction, though, it's going to be a negative exponent, 7 times 10 to the negative third power. In each of these examples, the way that we have written them as the product of a digit between 1 and 10 with a power of 10, when a number is written like this, it is known as writing it in scientific notation. Each one of these examples shows a number written in scientific notation. At this point, we are ready to formally introduce scientific notation. All right. Scientific notation is when a number is written in the following form: a times 10 to the nth power where a is a number that's between 1 and 10, and n is an integer exponent. It can either be a positive whole exponent or a negative whole exponent. All right, when a number is written in this form, we say that it's written in scientific notation. To determine the exponent for a number written in scientific notation, we again move the decimal point, but now we'll move it until we have a number that's between 1 and 10. If we move the decimal point to the left, that means it was a larger number, okay? And that will result in a positive exponent. But if we move the decimal point to the right, well, then that's going to be a smaller number, and that's going to result in a negative exponent. Let's check out some examples to make that a little clearer. All right, in example number 6, write each number in scientific notation. I have the number 2,500. Okay, the first thing that I have to do is realize where its decimal point currently is, and it's right there after that 0. I have to move this decimal point until I create a number that's between 1 and 10. If I move the decimal point to the left once, now it's the number 250. If I move it twice, now it's the number 25. But if I move it one more time, now it's the number 2 and 5/10, or 2.5. All right, I can ignore the zeros, and I can write this as 2 and 5/10, 2.5. All right, now that's my number that's between 1 and 10, and now I have to multiply it by a power of 10. 10 to what power? Well, I've moved the decimal point 1, 2, 3 times, and I moved it to the left. If we move it to the left, it will result in a positive exponent. So that means I'm going to have 10 to the third power here. Okay? Numbers that are larger than 10, like 2,500, are going to have a positive exponent. 47,300. Here's where the decimal point is. And again, I have to move this decimal point until I create a number that's between 1 and 10. So I move it once, I move it twice, I move it 3 times. That's 47 and 3/10. So I have to move it one more time, and that gives me 4 and 73 hundredths. Again, I can ignore the zeros. 4 and 73 hundredths times 10 to what power? Well, again, I've moved the decimal point to the left, so I know it's going to be a positive exponent, and I moved it 1, 2, 3, 4 times, so it's going to be 10 to the 4th power. Now, how do we know that these are actually correctly written in scientific notation? Okay, how do we know that we have the right power of 10? Well, if I just reverse course, if I do 4 and 73 hundredths, and I multiply it by 10 to the 4th power, remember that this decimal point is going to move to the right 4 times, and I should get what I started with. 1, 2, 3, 4. Fill in with a couple of zeros, and there I see 47,300. So I know that this number has been correctly written in scientific notation. Letter C, 19,050,000. Here's where the decimal point is. We have to move that decimal point until we get a number that's between 1 and 10. So let's move it left again. 1, 2, 3, 4, 5, 6. But that's 19, so I've got to move it one more time. And now I'm going to have 1 and 905 thousandths. All of these zeros I can ignore. Times 10 to what power? I moved it left. This is a bigger number, so I know it's going to be a positive exponent. 1, 2, 3, 4, 5, 6, 7 times I moved it to the right. 1 and 905 thousandths times 10 to the 7th power. Let's try some smaller numbers, numbers that are smaller than 1. All right, in this case, to get my number that's between 1 and 10, I'm going to have to move the decimal point to the right. So here I have 35 thousandths, move the decimal point once, and now it's 35 hundredths. Move it again, and now it's 3 and 5/10, which is between 1 and 10, just like we need. So this is going to equal 3 and 5/10. And now I'm going to multiply it by 10 to some exponent. If we move the decimal point to the right, it will be a negative exponent. I move the decimal point to the right once, twice, which means I'm going to have 10 to the negative second power. So we get 3 and 5 tenths times 10 to the negative second power. All right. How about with this number here? 10, 100,000, 10,000, 100,000, million, 724 millionths. Write it in scientific notation. Let's move that decimal point. 1, 2, 3, 4 times to the right makes it 7 and 24 hundredths times 10. And again, I moved it to the right, so it's going to be negative, and I moved it 4 times, so it's a negative 4. 7 and 24 hundredths times 10 to the negative fourth power. Finally, this last long decimal here, all right? I'm going to move that decimal point until I get a number that's between 1 and 10. 1, 2, 3, 4, 5 times creates 2 and 98 thousandths times 10 to the negative, because I moved it right, 1, 2, 3, 4, 5 to the negative fifth power. 2 and 98 thousandths times 10 to the negative fifth power. In our last couple of examples, we're going to practice writing numbers in scientific notation. Example 7 says that the radius of the Earth is about 6,380 kilometers. Write this distance in scientific notation. Okay, so my number is 6,380, right? That's the number of kilometers. What I want to do is write this number in scientific notation. So here's where the decimal point currently is. I'm going to move that decimal point until I create a number that's between 1 and 10. And to do that, I'm going to have to move left. Once gets me to 638. Twice gets me to 63 and 8 tenths. 3 times gets me to 6 and 38 hundredths. I can ignore the 0. So this is going to be 6 and 38 hundredths times 10 to what power? Well, I've moved it right, or excuse me, yeah, moved it left 1, 2, 3 times. So I'm going to have a 3. And remember, if you move the exponent to the left, that's going to be a positive 3. This is a bigger number. It's bigger than 10, so I know I'm going to have a positive exponent. 6 and 38 hundredths times 10 to the third kilometers. In example number 8, a human hair has an average diameter of about 0.000017 meters. Write this measurement in scientific notation. So let's go ahead and write that down. 0 and 0.000017 meters. We're going to create a number that's between 1 and 10, so I'm going to have to move the decimal point to the right. 1, 2, 3, 4, 5 times gives me 1 and 7 tenths. Times 10 to what power? Well, remember, moving the decimal point to the right is going to make that a negative exponent. This is a smaller number. It's smaller than 1, so my power has to be negative. And again, we started here. We moved it 1, 2, 3, 4, 5 times. So we're going to get 1 and 7 tenths times 10 to the negative fifth power.